Global users. In this tutorial, I'm going to demo you how to use this program to design the crane runway bin and the monorail bin. Okay, after you place your order, you will get the email from me. In that email, there's a link. By clicking on that link, it will direct you to this page. Okay, and it's a quick start page for you to start a program. Okay, so first of all, you need web browsers to run these programs. I would recommend to use Microsoft Edge as your web browsers. Okay, so how to start? Here's the link. It's this tutorial and there's a working sheet for you to download as a PDF file. There are three examples in these working sheet PDF files, and you use that PDF file against these videos step by step. You will start practicing three real design example, right? So, and there's an old versions of these programs. Existing user may still prefer the old version. They can go to old version by clicking on this link, and there's a quick tutorial here. And the input file you said before cannot be used for the new versions. So you cannot use the new version to open the old files. But the license can be shared between the old and new. So for the existing users, okay, and whatever license you have, it works for both versions. Okay. Before start the programs, you need to before start a program, you need to click on this link one time only, which is set you up for the crane modules, and you don't need to do this anymore after that. Okay, then click on Start Programs, and it will pop up a new windows here. So go to the General tab, and I would say we have three modules in this under the same interface. They are steel connection, concrete anchorage, and crane runway beam. So you are on crane runway beam. So the other two modules, you have to buy a separate license by clicking on this link. If you are interested in other modules and the other two modules, so they are separate license. So if when you start this interface, if it's not on crane runway being designed, you go to general tab and this pull down, you select the crane runway being. Okay. The other two field is a company name, project names, separate by a plus sign here. Before is company name, after is project name, and crane ID. So these fields will show up in the print out output PDF file as a title block. So I will address that when I talk about printing in the later section. All right. So and there's also when you move your mouse over, there's a two-tick pop-up. Okay, so you can turn this off by clicking this off button. Okay, this uh, general tab, company name, project ID, two-tick on off, switch to crane if not, switch to crane module if you are not. Okay. And now here, before you log in, you see here user is a guest and module crane one being is in demo mode. You are not registered user, so and you have to log in. Okay, guess how to log in. Okay, in that email, click on login button here. In that email, you get the login username and password from me and typing here and login. Okay, now you see here you get a username show up and register user. Okay, and here this status bar text box, and you see the calculation summary. We can find detailed calculation by clicking on this link. And the calculation summary design code, and you can, if you lost your license, if find your license is not uh, activated, you can click on this link. Basically, it just recheck out your license again. Okay. That's general tab. We are already logging, and you see here and your username here, general tab, and then we have to go to setting tab. Okay, and general tab. Pretty much, you use only once. You will not come back unless you want to change your project name, company name, and crane ID. All right, or you switch to other module. Other than that, you won't come back. And setting is a place where you set your design code. We have two, it's AISC 360, 16 and 10. We choose 16 and design unit as Imperial and the native unit for AISC code. And if you want to use metric for input and output, it's fine. Okay, click on this radio button. And also the display decimal or fraction, you can display as 38 as 38 or fraction or 0.375. I choose this one, okay, decimal. Click on OK. So we design code and design unit as imperial and display the fraction or decimal, okay? Click on OK. Then after that setting, unless you want to change to metric input, or you won't go back to setting again. So most of the time for crane runway beam design and monorail design, you are dealing with this crane tab and design calculation, these two tab. Okay. So here's a sketch area. Show the sketch of your runway beams, your wheel, and your plane layout, the crane beam span, and the bridge crane span. All right. So here's the input areas. You can choose top running, underhand, and monorail. Okay, and you can choose these cranes being section because there are too many parameters. So you can switch to different input by clicking on select input for. Okay, we will show more details on this when we deal with the design example. So uh, here's the status bar, your login user ID, ratios, calculation. There's a ratio here, result summary, but by clicking on design calc tab and when you do the input, you can know the final ratio right away. Okay, and when you lost your license, click on this link. Setting tab, interface sketch, input, save and load. Okay, we will show you how to save the input file and load the previous save input file. Okay, here, and you need not to log out. I think if you don't log out, next time you open the browser, it will log you in automatically without keying the username and password again and again. Okay, so the interface save text ball radio check license days. Alright. Okay. So basically, here now we have first things to do the design. We this part is dynamic. Okay, and based on this pull down. So you have choice of top running bridge crane, underhand bridge crane, and monorail beam. Three sub module. Okay. So and top running, you because there are too many data, you can select input for crane run weaving sections and crane data because you have lots of crane data to input, bridge weight, whatever. And we this program can handle two cranes in the same aisle at time. Okay, run at the same time. And each crane can have four wheels, or you can design one crane in the same aisles with eight wheels. Okay, that's a huge crane. Okay, normally more than 100 ton. So for that reason, there are lots of parameter you can switch these three pull down to switch the content of the input field below, and you switch back and forth. Okay, that will save you space. We have scroll bar here. Every time you do the input, you see there's a refresh. Okay, just be patient, and It's not. It's quick. Okay. Every time you do the input, there's a refresh. Okay. So just wait and select input for scroll sidebar. Okay. We have, let's say we have two claim run in the aisle, same aisle at the same time. We input claim one data here, and we can switch to claim two data, all right? And the second claim is here. So save you space, okay? So you can switch back and forth. Okay, then click on the runway bin sections, and you can input the claim runway bin here, all right? So once you set up your total running underhand and monorail, and the next is switch these pull down to switch between section of your input. Okay, so then these below that are dynamic input fields and to ref based on these pull down changes. Uh, okay, so I talk about this these question mark are actually two tip. Once you click on this one, it will show you the two tips. It's very slow. Why? Okay, it's the two tips of these explain what is input for, right? So this one is two tips. So every most of the input there's question mark on the right. You just create it's live the live menu for you to understand this input, right? Explain to you class C. These are two tip, all right? So, and if you don't know what's going on with this input field, click on the question mark beside it on the right side. Clear interface, input flow, refresh, two clean, one clean, two tick question mark, input field highlight. Okay. I talked about input field highlight. You see here, this crane being span, you move the mouse over here. This one get highlighted in yellow. So it just echoing where your input on the sketch, okay? What's your input on the sketch? So like this guy, bridge crane span, I move over here, you just highlight it, okay? And also you switch to clamping sections. If go to custom, all right? If go to custom input, you see here W shape. These are custom input depth. You see here, okay, highlighted, okay. French width, all right. If custom wide French with cap channel, you see here, this channel is very the guy is very thin, okay. Let's say 1 inch. You see, get 1 inch, okay. I move the mouse over, it get highlighted, all right. So these are highlighted text. When you do the input, you know where are those input in the sketch. All right. Tutti already talked about it. Okay. Every like this crane tonnage. All right. Crane tonnage. Capacity, bridge weight, hoist weight. There's a suggestion value. Suggest value. I mean, this brown color text. Okay. Uh, I would say that let's say we have one crane only. The number of wheel. Okay. Most of times, when user use design the crane runway being there's no vendor data available yet. Okay, like in the field, only in the very late stage. Okay, they get the vendor PO accepted, and after that, after PO, vendor crane vendor only give out data uh, after they get the PO. All right. So most of the time, the design engineer don't have vendor data. So we provide suggest value based on crane tonnage and the crane bridge span. It's very good resources, okay, for you to do a preliminary design when there's no vendor data available. So that's the suggest value you can keep. You see here, based on the crane tonnage and bridge span, I suggest you four wheels. Bridge weight is 19.58 keeps, you just type in, okay, if you don't have the vendor data. And also the static wear loads, let's say when they normally provide a static max static wear load, we can calculate that number based on uh, crane capacity and bridge weight and bri- bridge span, okay. But we if there's vendor data of maximum static wear load, you key in here. And the when the provide value and the calculated value, the maximum of the two will be used for design. If there's no vendor data, we only use the calculated maximum static wear load. Okay, so no vendor data, you just key in 0 here. And maximum of the two, the calculate value will be used for design. All right. So should I input the two tick question mark input field highlight text or you talk about suggest value? Okay, design calculation. The design calculation is here. You can expand one section by this one, right? It's all here. You can collapse it. Okay, so these section. You can click on sketch. You get a sketch here. Okay, you turn it off and there is one sections uh, called crane load on column, and that's for building design. And because there are that's the crane beam plus lift load, the reaction force on crane on building supporting column for building design. So we provide this one, but I don't know. If you you need to relay this reaction, maximum reaction to building for building steel frame design. Okay, I think some user don't is not interested in that. Like crane vendor, they only care about the crane beam design. Okay, so you can turn it off. Okay, so you can select all the section by clicking on deselect all the section, but the summary section is always on if nothing is selected. And let's say select all, and you can expand all. Like this one is collapse. Okay, expand all by clicking on this one. Okay, expand all the content. Collapse all. Okay, the concise format. Okay, and turn this off. You can expand one particular section by clicking on this title. Uh, Click on this title to expand it and click one more time to collapse it back. Okay, the concise format. Okay, so that's expand, collapse, or expand single, collapse single. Okay, you can hit the print button, and you pop up a new window, and you can right click and print. Okay, we'll talk about this later. And so these are design calculation. Sketch plan, there's a sketch. Okay, you can show the sketch here and bring together. Select all this, expand crabs, how to print. Okay, that's how to print. Okay, so let's say we select all, we expand then. Okay, we go to details. So it's all the detail, and when you want to print it, okay, hit the print button. That's the correct calculation, okay, in detail. And you move your mouse to the right margin and right click your mouse and you click on print, okay? And that's the edge print page. And click on more setting, make sure the headers and footer and background graphics are checked, okay? And for my experience, there are lots of PDF printer. I think use save as PDF. Okay, that come with Edge. Use choose save as PDF. Will give you the best resolution output. Okay, so and save. You see here the title block. I will talk about this one. Okay, save. And most likely it will point you to download page test print. Okay, test print. And open files. Oh no, I don't want to open in Etch. Okay, I want to open in PDF. Okay, open file. So you see here the title block, civil by engineering, whatever project, crane runway being crane one. So that's what you input here under general tab. So just give you idea, civil by engineering. Okay, before plus sign, after plus sign is the project ID. Okay, where's PDF? After, okay, so that's company name, that's project name, uh, that's a crane ID. Okay, so that's what you input here. All right, so you can, let's title block. Okay, you change your input here. It will show up. It will show up in the calculation output PDF file under the footer header. Okay. So that's the sample print, okay, PDF sketch, and it's unfolded, okay, unfold, okay. There you present to your book or client, okay, for approval. So that's for printing. Uh, no, okay. And how to print again? Show company name in the headers. Already show that. Check license status. Okay, if you lost your license, you click on this link one more time. Then you will recheck your license out if you still have the license. How to save and load? Okay. Okay. Now, after you finish everything and you're happy with your design, you want to save your file for next time review. Just click on the save button here. Okay, and let's say crane save one. Okay, save one, and hit the save button. It will save you to the download folder. Okay, okay, save you to the download folder. Okay, this is a txt file. So uh, next time you want to exit. Okay, so now you have file saved under download folders. This file, that's your. Okay, let's say we change this one and we load it back. Okay, claim being section, we change to white French. Okay, white French, white French. It's let's say then we want to load back our previous design. That's white French, and we load it. Okay, we hit the load button. Okay, and click the whatever file you saved before. Click on open. You will load back your previous save file. What? You will load back your previous save file. All right. So that's how to save and load file. Okay. Um, Now we start with the design example and show you three example on how to use this program. And before we start, we want to set everything back to eh, initial status. I mean, we have to key in the input by doing so. You need not to do this. But for me, just change the module to reset our clamping setting, okay? And now we set back the crane runway being we started the new. Okay, now we start from scratch to design three examples. Okay, show you how to do that, and that working sheet you download from this YouTube tutorial or that or here. Okay, working sheet. It's a PDF file. It's this PDF files. Okay, we will do the design three examples, and pretty much after these three examples, you will know how to do that. Okay, we highlight the design parameter. So first example, we have these uh, crane beams imperial input. Okay, W3099 plus channel 15 by 33.9 and span whatever. Okay, we just input a yellow shaded value here. Okay, so it's top running crane. Okay, first now we input the we make sure the number of crane in the same aisle is one, and the bridge span is rail to rail span is 50.4, and the eccentricity I explained to you. Okay, eccentricity is this value, left and right. Okay, so eccentricity it's column center to rail center. It's eccentricity. Where's eccentricity? Wheel spacing. Where's let me see. Where's eccentricity? Okay, that's 2.3. Okay, 2.3, 5.4, 2.3, 2.3 feet, 2.3 feet, and left and right, and now it's let's say AISC table section. So we have 1399, 15, 1399, agree, 1399, 1533.9, and 50 KSI, that's wide range yield and channel fatigue. A, you will see, you click on the question mark to know what's going on. And that's crane runway being section. We switch back to crane data. It's four wheels or how many wheels? Two wheels, okay, two wheels. And the tonnage of the capacity is 16.5. The bridge weight is 19.31 kips. The hoist and trolley is 9.58. The wheel spacing is 3.94. That's correct. When the maximum steel wheel load, we don't know yet. We input 0 here. The maximum or calculate when the value will be used. So we input 0 here to force to use calculate the maximum static wheel load. Okay. Hook approach limit is this guy. Okay, we use that for to calculate the maximum static wheel load by ourselves. It's 4.72. 4.72. The left, the right is 4.96. Okay, and CB, you check this question mark. Oh no, what's this? Okay, let's say we use 80. It's 80, and I put a question mark here, explain to you. Okay, class C 25. These are all question mark. I will explain to you why is that. Okay, and check the question mark on this. So I input these crane data. I think two wheel 90. I think I input most of things. Trolley weight, unknown, input 0, wheel spacing 9 point. Runway being span, okay, it's 36.9. This one already input. So runway being span, uh, we input that. Oh, it's not good. I input 33, 36.09, 36.09. Horizontal. You check the question mark on what's going on with horizontal. Okay, you will know that. Okay, 31.5, 31.5. I'll probably address you. Horizontal is we have vertical span column to column, but you not many users have these diagonal knee brace. Uh, mm, Braced to the top flange or the crane beams. Okay, so some users think the span, horizontal span gets shortened. Okay, because of the knee brace. So if you don't want to take advantage of that, you just keep in the same value here. Okay, and also L. You click on the question mark, you will know that. Okay, span, size. Okay, these are all done, okay? And I think we get the 0.94. We finish input the span data section. We finish input all the parameter for this top running crane, get the ratio of 0.94. Go to design calc and select all, and you get the all the say, okay. I assume you need the cramping reaction load on supporting building column. Okay, so this one you don't need that. You uncheck this one. Okay, you uncheck this one. You get the load calculation and AISC cramping code check 0.94. If you need that, just unfold it. And we already select all and expand all. Okay, expand all and you get a calculation. You hit the print button and okay, you print it. Okay, you only need to check this once. It will stay header, footer, and background graphics, and use Edge say as PDF, which give you the best output result. Uh, uh, Output resolutions for Sketch, I think, and save it. I go to download folder, save it, type in my first crane design. Okay, crane being design, my first crane being calc. Okay, so show in the folder. You see the open file, you open it, use Edge. I don't know. I don't want. I just click on this one. Use don't use the browsers. Okay, so basically it gives you the full calculations with first is low calculation, how is low is work out. Okay, and after that the code check. Okay, all the code check for crane one we've been designed. Okay, and after that is the crane load on building column. All right, so you can turn this part off if you don't need, and bumper force as well. So we finished example one. Okay, we finished example one. That one we can close this one. This pull up for printing only. I think I pull up 2 times. Okay, so now go back. We go to example two. You see here these low sections from we change to clamping sections. That's W1399. This guy, these dimensions. And that channel C1533.9, that's dimensions for this French depth, TWTF, the French thickness. Now, we get these data, so we try another way, okay? For example, two, we get these data here. Now we use the custom section option instead of AIC table section. I just show you example, you can do the build up sections for crane one will be build up girder. Because many times for heavy cranes, the low shape, library low shape doesn't work. Chance you are going to use the build up section, which is not from the library section. Okay, so we use this library section as a example. we do the use the build up to make it. Okay, the ratio will be close. I think it's 0.94, right? You see here. Now we're going to do the build up. Uh, build up. Let's say use this one is more intuitive. Okay, so let's say 15, 3.4.65. You see here. 15, 3.4.65 and zero point 0.4. So we use this one to do the build up, okay? Or you can use this one. Use this one to do the build up, okay? It's how you comment it. Comment it, okay? So use that guy. Use that guy to do the build up, all right? This one, or you use this sketch, okay? So now I'll show you how powerful our program is. We have choice of sections, okay? Double shade only. We can do the custom shade wide flange with cap channel or custom build up, okay? Now this one we have that one. I go to total, okay? So now it's 29.7. 29.7. Just build up. 29.7. French is 10.5. Top. You see the highlight here? You see the highlight here? Okay, 10.5. The bottom is 10.52. Uh, the French thickness zero point 0.7. Top 0.767. Bottom is 0.67. The web thickness is 0.52. And go to channel. The depth is 15. The French is 3.4, and the French thickness is 0.65. The web thickness is zero point 0.4. All right. So we now use the build up sections, get 0.93, okay? And make sure your steel yield strength is sometimes the build-up plate has lower yield strength, okay? But we assume the same for comparison. And I think for build-up, if everything is built up, these two guys will be the same value. Um, so now we see the build-up section is 0.93 and the library section is library section is 0.94, I believe. Okay, okay, 0.94. Or is it no calculations? Okay, 0.94 here. So we finished with example two. Example one with library sections, wide range plus channel, 9.94, and then we come to build up sections, okay, 0.93. Its calculation is also here. Okay, you can, same thing, you can expand or you can print. Okay, we already show that. So we finish example one, example two. These are almost the same with different option of ground ribbing section. One is from library, one is a spill up. Now we are going to do the design example three, monorail beam. Okay, um, that one, and you can choose underhung like this one. Now we choose the monorail beams, slightly different. And we are going to do a metric unit this time. Metric units, metric ton, meter instead of feet. Okay, we're going to use, I think it's 1200 something imperial, and metric is a 310158. because monorail 10 tons is very heavy. So the French thickness, local French bending is in high demand. So we need a thicker French plate. We cut from this one. That guy, 310 158. The French is too wide, and so we had to cut the French to fit the underhung wheel. Number of wheel is four. So we pick this one and we do the custom, okay? So monorail metric systems, we had to go to SAN design code AISC 36016. We changed to metric, okay? And now it's monorail and section we pick 310158. Let's say go to AISC section metric name is 310158. 158, 310, 158 is here. Okay. So, but the French is 310. French width is too wide for the underhung wheel, the trolley wheel. Okay. We had to cut it. So we go for custom section and we copy it, whatever. Okay. So you see, that's custom section. The French thickness 25, 1 inch. Now, the French width is too wide. We change to 200. Okay, it's a custom section. Update. Okay, so now it's custom sections. So basically, we get the 31015 color French. Okay, 200 as monorail beams. And we keep okay. It's a custom section. Custom sections. Okay, 354 is 50 kick. 50 KSI. 10 ton. Okay, 10 ton, and then trolley weight is 2 ton plus. It's very heavy. Okay, heavy side. The span 1 ratio. Uh, the span we choose 3 meters. You click on the question mark to understand what's the detail of this input. Okay, no cantilever 25 times. Okay, okay, that one is there for local French bending, right? So you need to input this one. I put the estimate the value here. You can use it. It's in the ballpark. All right. So we change to uh, again. That's for this input. Okay. For local French bending check. Okay. 22. You get this one. All right. So now that's monorail. You get expand all. We have local French bending based on CMAA 74. It's very local French bending. Most of the times governing factor, all right? So you can print it. And we have two ways local French crabs all. You see here, one check kind of sketch, all right? One check is a CMA 74. Another way is a simplified method. We have based on AIC paper here. And this one is always yeah, lower ratio, and this one is higher. That's governing ratio. So if you want to, I suggest you go for CMAA, okay, most of times, and do a safe design, conservative design. Okay, so you can bring out, expand all, and print. Uh, we already show that everything. Bring out this one. That ends our design example. For example 3, monorail. Okay, that's spec. And that concludes our tutorial. This one. Have fun with this program. Okay. Bye bye.